In the previous video, we saw how having inductive or capacitive elements in our AC circuit caused our current and voltage waves to get out of phase. And to help us discuss this in a little bit more detail, we're going to distinguish between two types of power within our AC circuits. We're going to discuss something called real power, which is power that is consumed by resistors. And we're going to talk about reactive power, which is power that is actually not consumed, but exchanged between inductive elements. So as this voltage source here begins to operate, any current or any energy that flows through this resistor is going to be consumed, because as we know, power is I squared R, and so based on the current that flows through that resistor, a certain amount of power is going to be consumed. So this is why we say that resistors always drop some voltage as this current passes through them. But with inductors and capacitors, actually no energy is really consumed. So in this particular capacitor, energy is consumed to build up this electric field, but then once the electric field is established, it's not destroyed. Like once the circuit rebounds, all that energy will be released back into the circuit. In the same way, with our inductor, all the energy is used to build up this magnetic field. But as we saw in first and second order circuits, once that voltage wave stops, that energy will be released back into the circuit. So while our resistive elements consume power, our reactive elements simply hold the power for a short amount of time and then release it back into the circuit. So when we talk about power for our circuit, we're going to have real power that's consumed by resistors, and we're going to have reactive power that's consumed by inductors and capacitors. And the idea is that reactive power is never lost. The source sends energy into these reactive systems, and then when the voltage drops, the energy comes back. And so power across a resistor is consumed and lost, but power that is delivered to an inductor or a capacitor is just simply exchanged continuously between that power source and that inductor and that capacitor. So if we had a simple circuit that was just a capacitor and an inductor, what would happen is that this capacitor would charge up when the voltages are high, and then when the voltages are low, it would discharge back into the circuit. And for this inductor, while the currents are moving frequently, this inductor would charge up, but when the current settles back down, it will get discharged back into the circuit. And this happens continuously because our voltage source is constantly oscillating between high and low values. So as this voltage source hits high values, low values, and then even zero values for an instant, energy is exchanged constantly between this capacitor and this inductor. So reactive energy is never lost. It is just constantly exchanged between the source and the elements. Real power is actually consumed because of our resistors. And what we're going to discuss is why some power companies really don't want to have a lot of reactive power. They don't want to send you a lot of energy and then have to take it back from you constantly during each cycle. So the major takeaway is that real power comes from resistive elements and is consumed. Reactive power is exchanged with the source continuously and is due to inductors and capacitors.